the angle reduces. Okay. Now what we have done is we have done a normalization. Okay, where we are making our if your classifiers accept data or give output in 0 and 1. Okay, it's better to make your input also in 0 and 1 for better processing of your blocks internally what you have, because internally, for example, if you take neural networks, okay, you have those activation functions, right? Now the activation functions could be 0 to 1 or it could be -1 to 1, right? It gets scaled, right? Now if you have, I think normalization, what you do is, if you have features which have lot of variations, okay, example, if there's a feature which is like 0 to 1, and if there's another feature which is 0 to 1000, right? Now there's a imbalance, right? So you try to bring it into one criteria. That's what normalization done. There are different methods of doing normalization. Okay, divide by max, right? So what I had used here is a I think it's a min max thing. Okay, you do with the mean value and divide it by sigma. Okay, so you do that kind of a normalization. That's normalized. Then I'm giving that my input to a Knan. Okay, Knan thing. Okay, now in Knan, so when there is a model, okay, first you have selected a data, what features, then you have model. Okay, you might select a, like for example, I have taken Knan here. Now every model has to learn, and for learning, it will have some kind of a parameters, and which we have to fine tune it. Okay, for example, here the neighbors is the parameter. Right now you can have multiple neighbors, 1, 2, 3, 4, 5, 7. Right? Okay. Now you can't have, ideally you go infinity, like such that every data has one neighbor, but it may not be possible. Right? So you can. So I started with 1, 3, and 5. Okay, so I have used that samples. Now class H is healthy, F is faulty. Okay, and I have given this data to different cases, like when my K, which is a variable, is 1, 3, and 5. So I have done this thing, and I am getting this result. Okay, let's say for example, if my for sample 1, if I am giving my actual class is healthy, my output is also getting healthy. Okay, so once you get this, after that you want to calculate what is my accuracy of my system. So that's where you look at the classification performance. Okay, I think confusion matrix, I think you are very well aware, right? So you try to calculate the what is my accuracy or misclassification. I think these are the two critical ones. So here we look at based on my, for example, for pump 1, when K is 1, 3, and 5, it is giving 100%. Whereas for pump 2, if K is 3, it is giving 80%, 86%. Right? So based on that, we have to optimize that. Right? Now, but these models are similar, right? Then how do you do a generalization? So in that case, probably Knan is not the best one. Okay. Then probably you have to have, because you can't have same pump. For one pump you make K as 1, another pump you K have 3, because you can't have multiple algorithm implemented for lot of machines. You can't do it practically, right? So you have to have a model, okay, where it is generic in nature. Okay, maybe probably we apply Knan here, probably ANN here, probably it might give better. Or if you do more SCM, probably it might give much more better results. Okay, so where more generalizations is there. Okay. So let's take an example of same thing where I applied the neural network here. Okay, so I am so the same value, what is 2.2, what we have seen same example, I am giving this here. So here I have the leakage and no leakage data. Okay. So here I have done again the same normalization. I have the hidden layer. Okay, now hidden layer is you want to optimize how much should be my hidden layer. Okay, it could be any number of things, right? As the hidden layer increases, your complexity calculations increases. Right? Now how do you optimize this. So easy is you do a simple trial. You can run these experiments easily. Like say you're doing MATLAB or Python, you can run a loop and it calculates, and then you can. For example, I did from 1, 2, 3, 4, 5, and 10. Okay, but there is also some kind of a relationship between number of inputs and number of hidden layers. Okay, so you can't go beyond or some level of input features. So there is some kind of a mathematical expression where you can calculate how much max your hidden layer could be. Okay, it is not right now on top of my mind, but some kind of a expressions where I can't go beyond 100. There is some kind of a thing based on my input levels. So here, if you see, from 1, 2, 3, 4, it varied from 46 to 60%. But when I went to 10, okay, it again went to reduces. Okay, that means 10 is not good. Okay, even if you have more number of hidden layers, it is not giving you good result. Okay, so at 5, it gave me the best result. So I decided, okay, my 5 is my best thing. So once you decide, okay, 5 is the best, so this is a developmental stage. After that, you have to verify. So you run with your algorithm with 5 neurons, then you give data which is not seen by your previous model. Okay, because here neural networks, you have weights, right? Now you optimize your weight, the weight is fixed. Now you give your unknown data. Maybe let's say your input data is 50%, 0 to 50% load. Now you are giving a data which is at 75% load or 100% load. Right? You need to see whether my model works or not for unknown data set. So probably let's say from 100% it coming to 80%. Right? Then you have to fine tune. Then what you do is you add this unknown data set to your training set. Then again you fine tune. Okay. So make sure you try to give data which covers the whole machine operation. What you see duty cycle. Okay, the duty cycle. Now duty cycle also can vary a lot. Right? Now, for example, when we had an hydraulic slab. Okay, we had a big piston pump, then we had a cylinders, and then we had oil, and then there were tank. So it would circulate. Okay, and then you can do experiment at static level. Okay, 25% load, 50% load, 7500 with certain output pressure. You can conduct an experiment at certain pressure, at certain triangle. Okay, now you can do at individual level, or you can program. It could be, let's say, I want to have first 1 hour at 25% load, next 1 hour 50% load. Different combinations we can do. One of the applications this had was in a excavator machines. So we were working with one of the manufacturer. So the excavator had a piston pump. Okay. So we looked at what an excavation duty cycle would be. Okay, for example, there's an excavation machines. Okay, the operator goes down. Okay, it lifts the bucket, it comes up, it goes here and dumps. Okay, and that's a duty cycle. So we looked at various duty cycle, what is the duration, what pressure it works. Okay, now the same duty cycle we try to implement in lab. It would be a scaled down thing. Okay, it would be a scaled down version of it. So that you try to bring those transients with it. Okay, that's how we do experiments and collect data. The data collection is important. And this was simulation model. Then we also got a real fracking machine data coming from the, let's say we had an oil and gas thing, so we got data and we are trying to see how things were matching. So we had a deviation, then we keep on working. Yeah, so this is how the approach was. Like KNN one example, neural network one example. Okay. Now here also the quality of data is important. Okay. Now for example, let's say I have